Welcome back. This is Mr. Hassan's Maths channel, and now we are on question number 6 from the IGCSE Cambridge International Exam, paper 4, the extended syllabus for the 0580. It's paper 4 variant 1 from May-June 2020. This question here is about linear programming. So it says here, Rahim makes baskets and mats. Each week he makes X baskets and Y mats. He makes fewer than 10 mats, and the number of mats he makes is greater than or equal to the number of baskets he makes. So the number of mats he makes is Y, and the number of baskets he makes is X. It says one of the inequalities that shows this information is Y is less than 10. Well, that's this one here. He makes fewer than 10 mats. Y is less than 10. Write down the other inequality. So this is the one here. We have to write down the number of mats he makes, which is Y, is greater than or equal to the number of baskets he makes. That was pretty easy, wasn't it? The number of mats, Y, is greater than or equal to the number of baskets. That's it. That's 1 mark for that. That's 6A. Now for 6B. He takes 2¼ hours to make a basket which was X, and 1½ hours to make a mat, which is Y. Each week he works for a maximum of 22.5 hours. Show that 3x plus 2y is less than or equal to 20. So I'm going to change 2½ into an improper fraction. That's going to be 9/4. 4 times 2 plus 1. So the number of hours he needs to make the baskets, if he takes 2¼ hours to make X baskets, is 9/4 times X. That's 1 basket. That's for 1 basket. This is for X baskets. The number of baskets times the number of hours it takes him to make 1 basket will be the total hours he spends making baskets. And the time he works making mats is 1½ times Y. So if I add to that 1½ which is 3/2 as a improper fraction times Y, that's the total time it takes him to make the mats. So this in total is the time it takes him to make the baskets and the mats, and he can work for a maximum of 22.5 hours. So the number of hours he works must be less than or equal to 22.5. Okay, now what I need to do here is I need to get rid of the fractions because I want to express it like this. So if I multiply both sides by 4, which is the LCM of the denominators, that will get rid of the fractions. So if I multiply this term by 4, I'll get 9x. And if I multiply this term by 4, I'll have 3 times 4/2. The 2 and 4 cancel if you 2, I'll have plus 6y. And if I multiply this term, it's not equals, it's less than or equal to. If I multiply this term by 4, I'm going to get 4 times 20, which is 80, plus 4 times 2.5, which is 10. That's going to give you 90. Let me just make sure in case I did something silly there. 22.5 times 4. 90, that's right. Now, this is not the same as what we have here, but we can see that each of these terms is divisible by 3. If I divide them each by 3, I'll have 3x, I'll have plus 2y, and less than or equal to 30. So that's what we've shown through these steps. So there we have part B done. Now for part C, on the next page, it says on the grid, draw 3 straight lines and shade the unwanted regions to show these inequalities. So the 3 inequalities were y is less than 10, y is greater than or equal to x, and 3x plus 2y is less than or equal to 30. So we had y, I'll write them up here, y is greater than 10, and y is greater than or equal to x, and we had 3x plus 2y is less than or equal to 30. Let me just confirm that those are the inequalities in case. Y is less than 10, okay, and y is greater than or equal to x, and 3x plus 2y is less than or equal to 30. Okay, so they're all right except for that one. You should always make sure. Okay, y is less than 10. Okay, so now we need to draw 3 straight lines to show these inequalities and shade the unwanted regions. So what we're going to do is these are the regions. When you have inequality signs, it shows a region. And what we need to do is show, first of all, find the line, which is like the boundary for that region. So we got to draw the line y equals 10 and y equals x and 3x plus 2y equals 30. Those are the three lines we have to draw. Now y equals 10 is not a big deal. It's going to be a horizontal line passing through 10 on the y-axis. So I'm going to draw that line, not make it too thick. The thinner you draw it, the better. So I'm going to try and make it very accurate along here. That's y equals 10. That's the line y equals 10. That's pretty simple. So horizontal line, everywhere on that line, y equals 10. Then we have y equals x, which is equally as simple. The line y equals x. Now I'm going to just zoom out a little bit so we can see the grid properly. I'll zoom out a bit more even. That way we can see the grid like as a whole, almost. It's okay. So y equals x is going to, that's basically a straight line, slanted line, which has a gradient of 1. If you think about it as y equals mx plus c, it has a gradient of 1 and the y-intercept of 0. So the gradient of 1 and the y-intercept of 0, you can also think of it as when y equals x, the x and the y coordinates will always be the same. So when x is 0, y is 0, and when x is 16, y is 16. Okay, so I could just join those points together. I could just join those 2 points together with a straight line. So I can just take my straight line and join the origin to that point at the top of the page. Okay, just make it a bit more neat, accurate. Of course, you're going to use a ruler. It's a good idea for you to take a 30 centimeters ruler in to the exam with you so you can draw the lines accurately and not have to do little parts here and there. So that's y equals x. So that's the boundary for this inequality. Y is greater than or equal to x. Now, one thing I have to mention about this line, this is y is less than x. Okay, so that means the line itself is not included. So what I should really do here is I should draw it as a dotted line. So I'm going to draw it as a dotted line, and that's one reason why you should always use, can I make it the dots a bit more further apart? Okay, I'm trying to make it into a dotted line. It's not really showing too well, but it's a dotted line. Okay, you can see it's dotted. That's solid. So that's why you should always use a pencil when you're doing these diagrams, because if you had done this with a pen, it's very difficult for you to correct it. So always draw lines and shading and diagrams with pencils. So I drew this as a solid line. If I was in the exam, I would just take the eraser and make some gaps in it to make it a dotted line to show that y equals 10 is not included. Y is just less than 10. And then we got 3x plus 2y equals 30. Now there's a nice, easy, simple way of plotting such a line like 3x plus y equals 30. 3x plus 2y equals 30. Okay, and what you could do here is you could basically use what's called, what I like to call the cover up method. So I've got 3x plus 2y equals 30. Let me take it to the previous page so we got some space, and we'll show the steps there. So let me take it to the previous page. So we have this, we want to draw the line 3x plus 2y equals 30. So a nice way of drawing a line when you've got both x and y on one side is if you make x equals 0. Now x equals 0 is the y-axis. That will tell you where the curve or the line hits the y-axis. So when x equals 0, this term becomes 0. You have 3 times 0, which is 0, and you're left with 2y equals 15. So 2y equals 30. I'm jumping the gun there. 2y equals 30. So you divide both sides by 2, y equals 15. So that's the point 0, 15. That's the point on the x-axis that the line is going to pass through. And when you make y equals 0, then you're left with, this term becomes 0, 2 times y is 0, you're left with 3x equals 30. So therefore x equals 10. That's the point 10, 0. So this line is going to pass through these 2 points. It's a straight line. It's going to pass through these 2 points, so we can plot it very easily. This is like some people call it the cover up method. So if you cover up the x term, we're left with 2y equals 30, y equals 15. If you cover up the y term, you're left with x equals 30, 3x equals 30, x equals 10. Covering up means replacing the x with 0. Replacing the x with 0 and replacing the y with 0, and you get those two answers. So 0, 15 and 10, 0 are the 2 points at which it crosses the y-axis. 0, 15 and 10, 0 the x-axis. So let's zoom out again so we can draw this a bit better. Okay, so now we can join those 2 points together with a straight line, as neat as possible and as accurate as possible. Okay, so that's going to go through there, and it's going to go through there. Both these lines are solid lines, as we can see. This is supposed to be a dotted line. Try to show it dotted as best as I can on this program. So we have this is the line 3x plus 2y equals 20. So these are the boundary lines for these regions. Now we have to do the shading. So first of all, y is less than 10. So that's the area below this line. It's below this line. So when we have to leave the unwanted regions, okay, well, when we want to leave the wanted regions unshaded, that means we have to shade the regions that we don't want. So I'm going to shade the region above this line. I'm going to shade the region above this line because I don't want what's above it, I want what's below it to be unshaded. So we're going to shade this region which is unwanted. So I'm shading this region, and I'm not thinking about the other two lines right now. I'm just thinking about this line. At the end, when we see what's left, we will then see how to deal with the rest of it. So then we have y is greater than x. Now this is the line y is equal to x. Y is greater than x when y is above x, when y is more than x. And y is more than x in the region above this line. You see all the values here, the y values are bigger than the x values. If I take this point, this is the point 2, 5. The y value is more than the x value. However, if I take this point, this is the point 2, 1. This time the y value is less than the x value. So y is greater than x in all the points above this line. So we need to shade what's below it because we want what's above it. So we got to shade this region below this line here. Okay, that's the unwanted region we want, where y is more than x. So this region now is going to be shaded. This is part of our unwanted regions. Okay, so there we have that shading done. We don't have to shade it like proper kind of, grade 3 stuff where you shade the whole thing. You can just draw these kind of lines to show it. That's perfectly fine. Then it says 3x plus 2y is less than or equal to 30. Well, this is the line 3x plus 2y is equal to 30. I should say 30 there. Okay, 3x plus 2y is equal to 30 is this line. We want to know, or we want the region where it's less than 30. Now, in general, that will mean, again, what's below the line. But it's always good to check. All right? It's always good to check. If it's in this form where the y term is on the left and it is a positive in front of it, it's a positive coefficient on the y term, then you can be quite rest assured that when it says less than, it means below the line. When it says greater than, it means above the line. But if you want to make a check and make sure, it's always a good idea to do so, especially if you have time to do so, just in case. So, for example, if you test a point that's not on the line, and of course the easiest point to test is origin. If it's not on the line, the origin is not on this line. So if we take the origin and we test it in this line, we see what the origin does to this inequality. If you put 0 instead of x, you're going to get 3 times 0, and 0 instead of y. If we test 0, 0, it's going to make this inequality say 0 on the left hand side, and on the right side it says 30. So 0 is less than or equal to 30. Is that true? Yes, it is. That means the origin is in the region which satisfies this inequality, is in the required region. So the unwanted region is the region above. So we have to shade the region above this line. So when we shade the region above this line, I've gone slightly too much there, no problem. So we can see what we're left with in the end is basically this region here. This region here, of course, is bounded by this x equals 0, because of course this is the number of baskets and mats that he makes, so you can't make less than 0. So it's bounded by x equals 0, and also these lines, it's like quadrilateral. All right, so this is the region Okay, this is the region, okay, which shows these inequalities. We've shown these inequalities, all right, by shading the unwanted region. This is a region that satisfies all of those inequalities. So if he does or makes the number of mats and baskets, mats was X, no, X was baskets. So this is baskets and this is mats. So this is baskets and this is mats. Y is mats. So if he makes, for example, any number of baskets and mats which fall into this area here, then he will be fulfilling his conditions, which were given about the number of hours he works, the number of mats he can make, and the number of baskets he can make as compared to the number of mats. So this is the region in which he can safely fulfill those three conditions that he had. Okay, so that's what we can deduce from that. So that's part C. Then it says he makes a $40 profit on each basket. He makes a $40 profit on each basket that he sells, and a $28 profit on each mat that he sells. Calculate the maximum profit he can make each week. So let's first find a expression for the profit. So 40 for each mat. Okay, the mats are Y. Sorry, yeah, the baskets are X. So 40 for each basket. So 40 times the number of baskets, 40 times X, the number of baskets are X, plus $28 per mat, and the number of mats he makes are Y. So 28 times Y. This is an expression that tells us the profit that he will make for the number of mats and baskets that he sells. Now, we want to find the maximum he can make. He can make mats and baskets that fall within this region here. Okay, that fall within this region here. Now, the number of mats and baskets he can make, the maximum value for any expression in any region like this will always be found, the maximum and minimum will always be found in the corners of that region. So, for example, the minimum, of course, here is if he makes 0 baskets and 0 mats, he's going to make no profit. That will, of course, represent the minimum. The maximum could be this point here, which is on the corner, which is 6 and 6. So we'll try that. But the maximum could also be on one of the other corners. Now, it can't be a fraction of baskets or mats. So I can't use, for example, 0, 10. I can't use this point 0, 10. That's because of the dotted line, because it has to make less than 10 mats. So I can't use 0, 10, but I could use, for example, 1, 0, 9. But we know that there's other values here which will be more than that. So those are not going to be the maximum. I can't use this point here because it's not a whole number. Okay, of baskets. It will be 3 point something baskets. I can't use that, right? Because it has to be a whole number. I can't use this number here because even though there's 3 baskets, he has to make less than 10 mats. So I could use, for example, this point here, okay, which is 3 and 9. I could also try this point here, which is 4 and 9. This is actually going to be more than this. So this is going to be more of a possibility. 4 and 9. Okay, that's 4 baskets and 9 mats. That's a whole number close to this corner. I think that's the closest we can get to it. All right, so I'm going to try 4, 9, and 6, 6 in this expression and see which one of those gives us the maximum profit. So let's try 4, 9, and 6, 6. So how do we try these? We substitute the value of X and Y into this expression. So let's try 4, 9 first. The profit for this is going to be 40 times the X value plus 28 times the Y value. And for this, it's going to be 40 times 6 plus 28 times 6 as well. And let's see which one of those gives us the highest amount, and that will be the maximum profit he can make. So we got 40 times 4 plus 28 times 9. That gives us $412. That's $412. And then let's try what this gives us. 40 times 6. Let's change this first. We can change these both to 6 now. That's 40 times 6 and 28 times 6. Now that gives us $408. So it looks like 49 has won the day. So it's $412. Okay, so in this case, you got to be careful. It's not this corner. It can't be this corner. Don't think, oh, that's the only corner there is. You got to test points that are close to those corners that you can't use because of various reasons, non-integers, dotted lines, and you've got to use those points which are close to those corners, the closest you can to those corners that will give you the highest value. I couldn't use this point, okay, which would have been 310, because it is on the dotted line where it can't equal 10. It has to be the number below it has to be 9. So that's what we have to show here. We could have drawn the line y equals 9 instead of y equals 10 if we wanted to, but we had to draw those lines represented by the inequalities. But that would be a valid line to draw for this situation, because you can't have values of y which are between 9 and 10, because you have to have a whole number of baskets and a whole number of mats. So that would have also been valid. Instead of drawing y is showing y is less than 10, we could have shown y is less than or equal to 9, and that would have been a valid way of solving this problem also. Okay, so that's the end of this question, I think. Yep. So that's question part D of question number 6. This question is a classic type of question to do with linear programming, where you have to know how to draw straight line graphs, you have to know how to construct inequalities from worded problems, you know how to do the shading for inequalities, and also write expressions, algebraic expressions for the profit, and realize that the maximum minimum values for any of these type of expressions will be found in the unshaded area on or near the corners. If the corners can be used, they will definitely be on the corners. If they can't, you have to choose points near those corners. So that's the answer to this question. Other questions from this paper of May-June 2020, International GCSE Paper 4, Variant 1, can be found in this playlist that should appear in this area. Other questions from this topic of linear programming can be found in this playlist over here, and you can subscribe to my channel by clicking on the link in the middle. Thank you for watching. See you soon.